Okay, we are doing lecture 8, part 2 today, which is going to be primarily talking about your point slope formula. Um, and we're going to use that to find equations of lines. We are also going to talk about your parallel and perpendicular and how that relates to using your point slope formula in finding the equations of lines. And then we will finish that thing off with an example of a test question. It will be on your quiz as well, where you guys are working through and using your point slope formula to help you answer a question. Basically, we're going to create a triangle that we know has a right angle. So, starting out with just a quick review, just to make sure that I've touched on this with you guys here. Equations of lines. So horizontal lines, what does the equation of a horizontal line look like? Well, all the points that are on this line, for example, this one here is 2, 6. We could say this one here is 4, 6. Okay. Going over this way here, we've got a negative 1, 6. Okay. And just kind of reiterating what we've talked about before. But all of these points that are on this line all have that same y value of 6. So the equation for this line is just simply y equals 6. It's all the points that have a y value of 6. So your horizontal lines are just y equals 6. When I was younger, I always struggled with that, so just trying to reiterate that to you guys here. Next one, we have a vertical line. So what does a vertical line look like? We'd have a point here. We'd say that's 3, 2. You got a point up here. This is 6, 2. Wow. I'm so sorry. We got a point here, and this would be 3, 4. Sorry about that. Got a point down here. We could say this is point 3, negative 3. So what do we have for this one here? Well, all of our x values are the same for this one here, and all of our x values are 3. So the equation of this line, a vertical line, is simply that x equals 3. So when I'm trying to come up with equations for lines like that, I am always just going to be basically ensuring I'm going to write out points and figure out which variable is constant. Is the x constant or is the y constant? Okay, so let's get to our point slope form. So what is our point slope form? Well, we actually get our point slope form from the equation for slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The difference is, though, we only know one of these points. So since I only know one of these points, I'm just going to leave this as an x and as a y. Okay, so instead of the x sub 2, y sub 2, we're just going to leave those as a variable x, y. And we're doing that because that is another point on the line that we don't know. Okay, and that's fine. So what I'm going to do to get this into the point slope form is I'm going to get rid of this fraction. And if I multiply by that there, those will cancel. But I also have to make sure that I do that on the other side as well. So I end up with x minus x sub 1 times m equals y minus y sub 1. Now, we typically will write that. So all I'm going to do now is I'm just going to change sides because we will typically write that as y minus y sub 1 equals m times x minus x sub 1. And that right there is your point slope formula. Okay, and that's what we are going to be using today is that point slope formula. So, moving on down to the next here. Find the equation of a line that passes through the points 2, 3, and negative 4, 5. Okay, well, I can't use my point slope formula because right now I don't know what my slope is. So the first thing that I need to do is I need to identify, hey, what's my slope of this line here? I usually like to make that my second point and then make this here my first point just because it goes in order, but it doesn't matter which is our second and which is our first. Okay, so when I do this here, I'm going to go m equals y sub 2, so that would be my 3, minus y sub 1, so that would be my 5, over my x sub 2, which would be my 2, minus my x sub 1, which would be my negative 4. Okay, and I'm going to need to simplify this. So as I'm going down through, 3 minus 5 gives me a negative 2. 2 minus a negative 4, those two negatives will make that a positive. So that would give me a positive 6. And I find that my slope is negative 1/3. So negative 1/3 is my slope. Okay. Now I have a slope, and I just need to use one of the points. It doesn't matter which point I use. I'm going to use this point here just because it has that negative so that we can talk about that as well. Okay, so we have our slope, we've got a point, so now we're just going to plug it into our point slope formula. Okay, so I will have y minus, what is my y sub 1? Well, that would be my 5, equals m. My m is at negative 1/3, okay, times x minus, my x sub 1 is that negative 4. Okay, so they want to know the equation of the line. Well, the equation of the line is just saying what is y equals mx plus b. So we're trying to get it into this form here. Okay, so first thing I need to do, those two plus signs, okay, that's going to give me y minus 5 equals negative 1/3 x minus 4/3, because negative 1/3 times a positive 4 would give me a negative 4/3. Last thing I need to do, add 5, okay, and that will give me y equals negative 1/3 x, and then it's a negative 4/3 and a positive 15/3, okay, so that would give me a positive 11/3 for my answer. So that is the equation of the line there. Now, I did it this way because I like to find my common denominator, but you guys have calculators that will do that for you as well. Okay, so that's essentially what you do for your point slope form. Sometimes they will give you just a single point and a slope, so you will just plug it directly into that equation there. Sometimes they give you 2 points, so you're going to have to find the slope first and then insert it into your point slope formula. Okay, there are a couple problems that I want you guys to pause the video. Oh, we don't need to do this one. Sorry, you can skip this slide because we already did it. Okay, but the next one down, here's an example. Here's an example. I want you guys to pause the video and try those there. Yep, pause the video, try those there. Okay, hopefully you guys have that video paused. Okay, so we've got a point and we've got a slope. So I'm going to plug that directly into my y minus y sub 1 equals m times x minus x sub 1. So y minus a negative 2 equals a negative 2 for my slope, x minus 1. Two negatives make a positive, y plus 2 equals, distribute that negative 2 in, so I get a negative 2x plus 2. Now I would need to subtract 2, and I get that y equals just simply a negative 2x, because those two would just end up canceling there. So y equals negative 2x would be my answer for that one. Other slide down below, okay, again, y equals, sorry, that is not the equation. We would go y minus, don't have a pen, y minus y sub 1 equals m times x minus x sub 1. Okay, y minus, my y sub 1 is a 0, equals m, which we know that our m in this case is 1/3, times x minus a negative 3. Two negatives, make a positive there. Y minus 0, well, that's just y. I need to distribute that in, so I get 1/3 x, and then 1/3 times 3 would just be a positive 1. Okay, so those are our two examples for our point slope form. The next one we're going to do is we're going to talk about parallel and perpendicular lines and how those affect